Greetings to everyone. My name is Kelvin and George Joles, and today I'm going to present my final year project entitled Simulation Study on the Performance of Water Distillation Units in Gas to Liquid Technology. So this project is under supervision by Dr. Nazri Abdul Rahman. There are four presentation outlines that will be given today, as shown here. So firstly is the introduction to the research. So Fischer Tropsch reaction is actually a synthesis process whereby a reaction between reagent, hydrogen and carbon monoxide in the presence of catalyst is known as the surface polymerizations. As shown in chemical reactions, the combination between carbon monoxide and hydrogens produce long chain of hydrocarbon, but this produce water as a byproduct, as shown in these figures. It's in a white form water because of oily structure. So based on this issue, this project is focused to study on the Fischer Tropsch water composition and its effects on the wastewater chemical oxygen demand by using Aspen simulations. So to achieve these aims, four objectives has been formulated, as shown here. But this objective is governed by a scope which focus on the distillation process, the volatile organic compound, and the chemical oxygen demand at the bottom stream of the distillation column. So research methodology is a four section has been divided to achieve the aims, consists of Objective 1, Objective 2, Objective 3, and Objective 4. Involve the literature review and process design, simulations of Objective 2, and the case study is the heart of this research, and lastly a mathematical statistical modeling to obtain an equation before we reaching for the aim. So this is the Gantt chart, indicates that my timeline of doing this research since September 2019 and until today, July 2020. So the results and discussions, this is the important part of these presentations. Stage 1 has been accomplished by doing the literature reviews, has been suggested by Martinez et al. A water distiller can treat the Fischer Tropsch reaction by producing the overhead products and a bottom product. So the bottom product is mainly consists of processed water, or known as wastewater. So based on this literature review, the compositions in the Fischer Tropsch water has been identified as shown in table 1. So the target of this research is to process and reach water stream at the bottom. So based on the composition, a process block diagram has been developed, consists of 3 sections. With section 100 is for the stripping of volatile organic compound. Section 200 is the enriching the liquid organic product, and lastly section 300 is to treat wastewater with a neutralization process. So a process flow diagram has also been developed that involves the major equipment as shown in this figure 2. Major equipment is the water distiller, a separator, and a mixer. So once we're done with the process flow diagram formations, thermodynamic has been selected between non-random to liquid and unique weight HOC. So after running the simulation, it is found that unique weight HOC has high R square, which is at 99.52% rather than NRTL 99.34%. A slight difference, but it actually matters a lot in this simulation because this indicates that unique weight HOC is suitable to analyze multi-component separation. So this unique weight HOC thermodynamic model is recommended to be used as suggested by Kelly and Clark 2015. But due to the high R square, this model is chosen in this research. So Aspen simulation has been run based on the flow diagrams and the thermodynamic models. So we can see in table point 2, product distribution with Aspen simulation. We focus on the water productions, and the fit is 98.89%. In the processed water, we can achieve 99.91%, which is about increment almost 1% of the water composition at the bottom. And see the COD has decreased in processed water from triple bottom at less than 1000 ppm. And this model has been validated by comparing with actual plant data from the natural gas processing industry in Bintulu. As shown in table 3, the deviation from work done by each equipment in section 100, section 200, and section 300 has averaged less than 10% at 5.52%. And in table 4, enriched water stream, it should indicate that the deviation between Aspen simulation and actual plant data also indicated less than 10% deviations between the operating temperature and the component compositions at the enriched water stream, which is the bottom stream. And in table 5, the product separation also shows less than 10% deviation. So all of these indicate that less than 10% deviation to show that Aspen simulation has similar operating condition and operation with the actual wastewater distillation unit in the natural gas processing industry. So after the model validations, the research focused on the case study, which is the heart of this research. It's divided into two cases, which is the variation of Fischer Tropsch feed composition as the case 1. So alcohol has been verified from the compositions 0.71 to 0.85%. It shows that significant changes in the alcohol COD of the feed. And the same goes to the aldehyde, increase in the composition but shows the constant trend. And ketone also shows the same trend to the feed COD and as compared to the carboxylic acid in table 9. So this indicates that alcohol, aldehydes, and ketone composition variation feed do not affect wastewater COD. And a small increase to alcohol composition concentration feeds leads to high feed COD. As such, water distillation unit is essential to strip off volatile organic compound, which means that light component is recovered at the top and the heavy component is recovered at the bottom of the distillation column will determine the COD of the stream. And the research also proceed with the case 2, which is the chemical oxygen demand removal efficiency. So after the distillation column, which is at the strip bottom, the COD removal efficiency for alcohol, ketones, and aldehyde is above the red line. So the red line indicates the minimum removal. But for the carboxylic acid, the COD removal efficiency goes beyond lower than red line after 0.09% of carboxylic composition. Or what does this mean actually? When the alcohol, aldehyde, and ketone composition increases, the COD removal efficiency increases. Because these components are volatile, so it's easy to strip off from the feed. But it doesn't happen to the carboxylic acid. As it increases, the COD removal efficiency decreases because it's more carboxylic acid has been recovered at the strip bottom. So to mitigate this issue, especially on carboxylic part, neutralization has been introduced, and it can be seen in figure 7, 8, and 9 that the removal efficiencies goes beyond than almost 97%, and the same goes to the carboxylic acid. You can see that the variation of the composition only does not still have the removal efficiency more than 95%. So what does this mean is that neutralization has a significant impact to the COD level at the strip wastewater. So this has been supported by two literature reviews, with Ahad 2050 and Coronado 2009 informs that neutralization increased the COD beyond 95%. But in this Aspen simulation, it indicates that the removal efficiency after the neutralization process is 97%. So once the case study is completed, a statistical modeling has been done. A wastewater COD equation has been formulated with the 5 parameters such as alcohol, aldehyde, ketone, carboxylic acid, and water. 6 constraints has been introduced as shown here to govern the equations, which is on the assumption leading to the usage of the equation. So these equations has been verified using ANOVA. If the F value and P values is valid because F value is more than 1 and P value is less than 0.05. Same goes to the regression statistics. The R value, R squared, is more than 75%, which in this research is 97%. And then lastly, the residual error is within 2% deviation among the predicted, as in the dotted line, and the dotted line is the actual data from the Aspen. So this model is valid, can be used. So in conclusions, there are 3 sections that has been designed in the wastewater distillation unit. Is distillation, recovery, and neutralization. And also a steady state simulation is run with UKHOC to show that 10%, less than 10% deviation between the actual plant data and the Aspen simulation. And variations in alcohols, aldehyde, and ketone composition do not affect the wastewater COD, but it's happen only for carboxylic acid. As such, neutralization process is being introduced, so the removal efficiency increased by 97%. So lastly, wastewater COD is predicted based on the Fischer Tropsch water composition as shown in the last stage of this research. So the recommendation to improve this research is to conduct economic analysis, because it's given mass and energy balance, it's possible to calculate the economic issue problem. And second is to broaden the scope to ammoniacal nitrogen and hydrogen sulfide, because these two is very important in processing industry. So lastly is conduct a heat integration analysis, because water distillation unit involve a few heat exchanger fluid. So this ends my presentations. It's a great opportunity to do research with Aspen simulation in Unimas, and thank you for listening to my sharing.